This German company manufactures model Stirling engines and entertaining accessories driven by them, like this marble tower. The engine parts are moved by a closed loop of air that circulates inside the engine, expanding and contracting as it repeatedly heats and cools. The company's owner designs the engines and produces technical drawings for each component on the computer. The dimensions must be accurate within 1/1000th of a millimeter. A computer-guided turret machine shapes the engine's cooling cylinder out of a solid piece of brass. Brass loses heat quickly, making it ideal for a component whose job is to rapidly reduce the hot air temperature by about 200 degrees. The cooled air contracts, producing a vacuum that sucks down the engine's working piston. When reheated, the air expands, pushing the piston up again. That repetitive motion drives the crankshaft. The cooling cylinder has fins to help diffuse heat, a hole on top for the working piston, and another hole on the side for the displace piston. After cleaning the cylinder with compressed air, a technician performs a quality control check. First, he inserts a series of test pins into the hole for the working piston until one fits perfectly. This tells him the diameter measurement. Using a digital caliper, he measures a series of aluminum working pistons until he finds the one that's the correct size for the hole's diameter. He inserts the piston into the cylinder, then holds the cylinder upside down. If the piston falls out slowly, it's the right size. The fit must be precise to prevent the circulating air from leaking out of the cylinder. In the assembly area, a worker superglues a crankshaft ball bearing into each of the engine's 2 stainless steel side frames. She glues the displace axle to the displace piston. It must fit more loosely in the cooling cylinder to allow the air to flow around it while moving back and forth between the engine's heating and cooling zones. She inserts the displace piston into the side hole of the cooling cylinder. Then she mounts the heating cylinder over the piston. The heating cylinder draws heat generated by the flame into the engine. She attaches it to the cooling cylinder with 4 screws. She attaches a connecting rod to the working piston and inserts the piston into the cooling cylinder. She mounts one of the side frames to the cylinder, attaches a rocker arm to that side frame, then puts one end of the crankshaft through the side frame's ball bearing. She attaches the second side frame, inserting the other end of the crankshaft through its ball bearing. She mounts what she's assembled so far onto a wooden base plate, then connects one end of the rocker arm to the working piston's connecting rod. She connects the other end of the rocker arm to the crankshaft connecting rod, which is at a 90-degree angle to both the rocker arm and the crankshaft. On each end of the crankshaft, she mounts a heavy brass flywheel. The flywheels increase the momentum of the engine. To power an accessory with the Stirling engine, you run one end of a drive belt around a pulley on the accessory and the other end of the belt around this plastic drive wheel. The finishing touch is an engraved brass identification plate. Here's how this engine works. You fill the burner case with denatured alcohol and attach the wick. You place the burner case underneath the heating cylinder, light the wick, let the engine preheat for 10 to 15 seconds, then turn a flywheel to kickstart the engine. The flame heats the air inside the heating cylinder. The hot air expands, moves into the cooling cylinder, then cools and contracts. This moves the working piston up and down, turning the engine's crankshaft.